Rosenfeld is a two-time appointee to the California Energy Commission and one of the architects of energy efficiency research. He received his PhD in physics in 1954 under Nobel laureate Enrico Fermi, then joined the Department of Physics at UC Berkeley. There he joined and eventually led the Nobel Prize-winning particle physics group of Luis Alvarez at Berkeley Lab until 1974. In 1974, he changed to the new field of energy efficiency research. He formed the Center for Building Science at Berkeley Lab and led it until 1994. From 1994 to 1999, Dr. Rosenfeld served as the Senior Advisor for the Department of Energy's Assistant Secretary for Energy Efficiency and Renewable Energy. Today, his legacy of research and policy work has been credited with yielding an astounding annual savings of around $100 billion in the U.S. And without further ado, I'd like to everyone to welcome Dr. Rosenfeld for this lecture.
Thank you. I'm going to run through a bunch of slides with some apologies to old friends in the audience. Some of these slides haven't changed in 30 years. I've had one obsession for 30 years, which is that energy efficiency is a good way to get the environment cleaned up, to save money, to get around petroleum dependence, and now to delay global warming. And as I say, things change a little bit, but only slowly. The very first slide is not that. It's just to show you that I really did work with Enrico Fermi. We really did publish this book together. You can see from the size of the type the relative importance of the names. Georg and Bob Schluter and I were his graduate students. No, we were just TAs at the time when he gave these first set of lectures after the war. To lead into the first slide or so, I'm going to hark back to the Fermi Award. About a month before the award, I got a phone call from Secretary of Energy Sam Bobman telling me that I'd gotten the award. And he said at the time, he said, I've got to write up some talking points to introduce you, and I think I'm going to email them to you and let you see if they're roughly correct. So he sends me some first draft in which it says that Art Rosenfeld has created a team of researchers and engineers who are saving the United States hundreds of millions of dollars per year. And I took a look at that and said, well, that's an interesting factor of 1,000 mistake. It's really probably around 200 billion, but I'll claim 100 billion a year for being conservative. And I'm going to show you some of those numbers now, but I think it is interesting that the powers of energy efficiency are such that people still make a mistake of a factor of 1,000, and some of those people are still at the Department of Energy. I will say one other thing that I think is sort of funny about the award. The award is officially presented by the president, who had other things to do that day. It was presented by the Secretary of Energy and two undersecretaries, all of whom gave incredibly and I think sincere respects to the importance of energy efficiency. But it was a little macabre because the previous time I had seen Undersecretary Dave Garman, who at the time had been Assistant Secretary of Energy Efficiency and Renewable Energy, he had been kidding me that he would be friendlier to the whatever request I had at the time if we weren't suing them at the California Energy Commission, because the Department of Energy is responsible for about 20 appliance standards which are supposed to be updated every 3 years, so that means they should update about 5 a year. The Bush administration has been in office for 5 years, and during that time all they have done has been to try to set back one standard the other way. and no other updates. So NRDC, accompanied by 10 states, is in the process of, 10 states including California, is in the process of suing the Department of Energy. At the same time, the state of California is trying to update fuel economy standards, which of course we're preempted from doing because of the federal fuel CAFE standards, corporate automobile fuel economy. We argue that CAFE was thought out in 1975, long before anybody thought of global warming. It was to reduce petroleum dependence and to save money, and that those desires are now trumped by the fact that it's actually a public health issue because the world is warming. So we have legislation which is going to increase the fuel economy of cars sold in California, ramping up to 30% and starting in 2009. The automobile agencies, the automobile industry is suing us. The federal government is a friend of the court on the side of the automobile agencies. Schwarzenegger is the chief representative of California, so Bush is suing Schwarzenegger. Meanwhile, the Department of Energy is giving me an energy efficiency award, so it's all it's all a little strange, but anyway. This is the $200 billion argument. This is a plot, and this is perfectly standard data. It appears every month in Monthly Energy Review from the Energy Information Agency. It appears once a year in Annual Energy Review, and it's a plot of what's called energy intensity, which is thousands of BTU per dollar of gross domestic product. And so that's something which should get better all the time as technology improves, but how fast it gets better depends on policy and price and so on. And the blue line here is actual, published monthly. The time scale is 1949 to a vertical line in 1973. That's the famous OPEC embargo when we first started thinking about energy efficiency and energy policy. And then a big increase in the rate of decline of this to today. If you try to define business as usual, I just put a smooth exponential decay. It's so small it can be linear. So the red line is what was going on from business as usual from 1949 to 1973. It has a mild slope and in fact averages 4% a year, 0.4% per year. Then two things happened. The price went up and we passed the corporate automobile fuel economy standards and we started responding in policy ways. And this decrease suddenly increased from 0.4% per year to 2.1% per year. And is down, if you call this 100%, this is down to about a half. So that's a huge effect in 20 years. Nobody noticed it very much. Nobody froze in the dark. But it is a huge effect. Now, this is the way Energy Information Agency leaves it. I tend to like to plot it one more area of detail. So this is now the same data, but in energy units. Same time scale, same vertical line. This is quads, 10 to the 5th, units of 10 to the 15th BTU. The blue line was growing rapidly as our GNP increased and then leveled off. And here's where we are today at about 100 quads. Actually, one figure of economics you might want to remember is that we're at 100 quads and our energy bill was $1 trillion a year. So there's a nice factor of 10 that's easy to remember. The red line is what would have happened if we had kept the red line on the previous chart, that is a mild decrease in energy efficiency instead of the sudden increase in energy intensity. And instead of being at about 100 quads today, we would be at about 170 quads today. And our energy bill, instead of being $1 trillion, would be about $1.7 trillion. With our brains, we have avoided spending about $700 billion a year, or 6% of our GDP, every year, or at least last year. Now, I want to say this important message in another set of languages. We were at 75 quads in 1973, and we're at about 100 quads today. So we physically increased our energy supply by 25 quads. So that's power plants, tankers, transmission lines, refineries, all that steel. But we've gotten by today's standards, we've gotten 175 quads worth of energy services, which means that there's a virtual 75 quads that we didn't have to build because we got smarter and our policies got better. So the physical supply is 25 units, the virtual supply is 75 units. 3/4 of all our new energy services have come from energy efficiency and energy policy, 1/4 from actual steel in the ground. That's been true for the last 30 years. That's probably going to be true for the next 30 years or the next 100 years. And in terms of figuring out how to delay global warming, don't forget that. The first thing to do is to go in for improved energy efficiency, improved energy policies, better automobile fuel economy, and so on. And then what you can't do that way, you do with steel in the ground. But it's cheaper this way. So, how much of this savings comes straight from energy efficiency as opposed to structural change? After all, it certainly is true that since 1973, we've exported first the aluminum industry. We got rid of that as we ran into power shortages. We now import concrete from overseas, but mainly it's an internal effect that we've gone from a smokestack economy to making chips and making money off of selling electronics and so on, and that's less energy intensive. So it's not all energy efficiency. I shouldn't claim it is. But some of the numbers that you can tease out are pretty big. Cars. In the early 1970s, we were at 14 miles per gallon. We're now at about 21. That's a mixture of SUVs and cars. If we were still at 14, we would consume 75 billion gallons more and pay $225 billion more for gasoline alone. That's 2% of our economy saved right there. If we go ahead and if this suit, the Schwarzenegger-Pavley suit works out, we'll save another $150 billion a year, because as soon as, if we win this suit, 10 other states will immediately pass the same rules, and that trumps the country, so we'll do a lot of good. Even commercial aviation, jets are better, is saving us about $50 billion a year. Appliances and buildings are more complex. I'll get to that in a minute, because there's so many different small things that we do, and they're not wrapped up into one index like fuel economy. So I tried one evening, not very carefully, to make the case that if energy efficiency had been frozen at 74 levels, what are we probably saving today? Well, in space heating, between the fact that we have somewhat more efficient furnaces, we've gotten rid of electric resistance heating, certainly in California and a lot of the world, and buildings are a lot more efficient and better insulated and better windows. We're saving about $40 billion a year. Air conditioning savings around $30 billion a year, and in California we are going to start thinking seriously about an appliance standard for a 20% improvement in air conditioning, which turns out to be cost effective. Refrigerators, I'm going to show you some plots on refrigerators, about $15 billion a year. Just fluorescent lamps in the ceilings, about $5 billion a year. Compact fluorescents, which were jump-started by research here, $5 billion a year. I wanted this to get to $100 billion, and I didn't quite make it. So just to be defensive, I decided to talk a little bit about standby losses, which Alan Meyer from here likes to call vampires. These are all the external power supplies which are all over your house, 10 or 20 of them. They convert 110 AC to 10 volts DC to run your computer, or charge your toothbrush, or charge your a couple of cordless phones around the house, or your cell phone, or your garage door opener, or power your TV, which incidentally has the property that it never turns off because it's waiting for a remote to tell it to do something, so it has to be vigilant all the time. We have passed standards in California. The federal government has never paid any interest in standby losses, but we have passed standards in California such that the average external power supply or battery charger, which now runs 3 watts, but there are 20 of them around your house, which now runs 3 watts, will come down to about 5 watts, to about half a watt, so virtually to nothing. It turns out that the extra cost to go from an old analog circuit with a little transformer and some diodes to a switching circuit where you can do this very efficiently turns out to be around 10 or 15 cents per power supply. I used to go around until a recent trip saying that the payback time would be about 1 month in saved electricity. It turns out that when my advisor, John Wilson, went to Taiwan recently and to China to tell them about the new rules which are going to become effective on January 1st, and tried to ask what the increase in price was, these things are all made in Taiwan and China. The manufacturer's statement was, we're not going to raise the price, it's not really worth it. So the payback time is 0. Okay, I think a fair summary says that out of the total $700 billion savings, probably a third of it is structural. A third of it comes from transportation, that's cafe and jets and so on that I just mentioned, and something like a third comes from technical improvements in buildings and industry. But I'm only claiming 100 billion, just to be conservative. One thing that interests me is that I seldom am on a platform agreeing with the Vice President. But this is a quote from the much discussed National Energy Policy Report. This is the one where the advisors were never made public. But the quote itself says, had energy, and Cheney is the lead author, had energy use kept pace with economic growth in the nation would have consumed 171 quads. Now that's the same number I showed you. Last year instead of 99. Well, we're at 103 now, but this is a 3-year-old report. So the interesting point is that the Cheney agrees with these numbers exactly. About a third to a half of these savings have resulted from shifts in the economy. The other half to 2/3 comes from greater energy efficiency. So amusingly enough, the Vice President says it's better than the Energy Information Agency. That was a surprise to me. I would like now to make some comparisons with California. There's a problem. This is a plot, the same plot in gray, except it only goes back to 1963, that I just showed you with E over GDP coming down. I said roughly to a half, actually to 54%. California did a little better. It came down to 46%. But the trouble is, it was going up with big economic growth before. So I don't know how to extrapolate. And anyway, the trouble with this is we're stuck with this terrible problem of fuel economy, which we're up till now haven't done anything about. So instead, everything else I say for the rest of the talk is going to be electricity only, where we control our own destiny. So here's the plot I like to show most. Per capita electricity sales from 1960 to 1972, and then that's the embargo, should be 73, and I meant to say that, and then on till today. The gold line is California, the gray line is the United States. Notice that until 1973, they were pretty similar. The United States was a little bit ahead of California for a couple of obvious reasons. I already mentioned aluminum on the Tennessee River or the Columbia River. And the weather is really worse in Chicago, as I know, than here. So a little more electric resistance heat. But they were both growing 6% a year. we woke up to the fact that a great deal could be done with energy efficiency, and we have stayed constant in electricity use per person. So population has grown 1 or 2% a year, but we stayed constant per person for 30 years, even though refrigerators are bigger, as I'll show you, houses are bigger, TVs are bigger, and there are more of them, computers are there sopping up electricity. But that's all been compensated for by increases in efficiency. The United States had access to the same information, didn't take it quite as seriously, has grown 2% a year, and is now up 50%. This blue wedge, which is the increase from the United States, 50% increase, corresponds to, at California prices, about $1,000 per family per year. At US average prices with a lot of coal and cheaper electricity, it's only about $900 per family per year, still a significant amount of savings. CO2-wise, how are we doing? Nobody knows which measure to use for CO2. One is tons of CO2 per dollar. That's probably the fairest one. The other is tons of CO2 per person. But in any case, up here is bad and down here is very good. And here's Western Europe and California, and here's the United States and Canada and Australia. So we're roughly twice as, we're heating up the world roughly only half as fast as the United States as a whole, which is, I think, something to be proud of. I wanted to make this remark. This is the same California in gold, United States in gray, to say that we're not the only state. New York takes energy efficiency very carefully, and you can see that they're as good as we are. And that's New York State. You like this one. You know, there's a good economics master's thesis in here. It's really quite, there's a lot of cause and effect and interesting problems mixed in here, but it's certainly true that the folks in the red states consume a hell of a lot more electricity than the folks in the blue states. And it's not all climate. Okay. To add a certain touch of reality to this, I want to talk about actual savings with actual equipment. This is a plot which is indexed to 100 at the time of the embargo. And the purple line is the improvement in refrigerators, so down to 25% of the energy used for larger refrigerators. The blue line is air conditioners. This is the only thing the Bush administration has done. The Clinton administration recommended on its last day in office an energy efficiency rating of 13. In his first day of office, Bush set it to 12. The courts, NRDC then sued the Bush administration and got it back to 13. And you can't do quite as well on gas furnaces because they were already like 60% efficient, and there's a real limit of like 92%. And then you start condensing water and you get problems with acid deposition. But nevertheless, this picture is pretty good. One thing that I'd like to point out is that the open arrows are California standards. The feds didn't get into the standards business until sort of over Reagan's dead body, literally after Reagan left office. So you can see that states are pretty important in this game. Whenever the California required better refrigerators or better air conditioners, it was so cheap that the manufacturers never bothered to make two sets of refrigerators for dummies and refrigerators for smart people. So they changed over all their lines anyway and paid. So I'm going to look at refrigerators for a minute. This is the start plot I apologized about because it's about 4 years old. 1947 to the embargo to today. Let's get rid of the blue, the whatever color it is, purple line first, which measures cubic feet of refrigerator, usable feet, square cubic feet. In 1947, it was 8 cubic feet. had climbed to 15 cubic feet by the time of the embargo, and then sort of leveled off at about 20 cubic feet. This isn't that we learned to cope with affluence. It's not. It's the refrigerator manufacturers haven't figured out how to make the architects make bigger kitchen doors. The energy use was going up completely out of control, like 9% a year until the embargo. This would have gone up here somewhere, but two things happened. The federal government quickly put out yellow energy guide tags, which allowed you to tell how much energy your refrigerator used, which was a huge help. And the California Energy Commission started developing refrigerator standards, the calculations being done right over here at LBL. So instead of going off here, there's a 90-degree right-hand turn. The refrigerator use is now down to from 1,800 kilowatt hours a year, which would be $200 a year at today's prices, to 450, which is about $50 a year at today's prices. And the boxes are bigger, and we got rid of the CFCs so we don't hurt the Antarctic ozone hole. And these are all pretty easy optimizations. It's a little better, more copper in the heat exchangers, a little better insulation. The electric motor's efficiency has grown. The motor of the compressor was about 40% at this time. It's now about 90%, and so on. More copper in the motors, better steel in the laminations. And interestingly enough, people say, well, conservation will get used up. But this is a 5% improvement every year for 30 years, and it's still going on. So the returns on investment get to be a little worse, but there's plenty of progress still to be made. This particularly interests me. This is the same plot you just saw, except there's the retail price in 1983 dollars for refrigerators sold at the time of the embargo and sold now. Now remember, we've required better insulation, more copper, better steel, so on. The price of refrigerators should go up a little bit, but you get your money back in 5 years. Well, in fact, what seems to happen is you pass legislation saying the efficiency of this refrigerator has to improve. The manufacturer then decides to give up his old 35-year-old cash cow assembly line and make a new one. He then puts in all the new technology that's available in the last 30 years, which is robots instead of people, better materials, so forth and so on, better machine tools, and the price comes way down. Now the price might come down even steeper if we didn't improve the efficiency, but in fact, nobody, I think, no economist can look at this curve and say, we have driven refrigerator prices off the roof. They've done pretty well, thank you. The environmental aspects of this are pretty amazing. This is the amount of energy used if refrigerators were still at 1974 efficiency. It's quite a lot of energy. I think it represents about 50 baseload power plants, and it's the brown line. This is what they actually use today. They're down to a quarter. The blue line is the energy savings. It's part of the wedge that I showed you before that we don't have to build power plants for. What is it equivalent to in some more familiar measures? This is the same scale, billions of kilowatt hours a year. This is the blue I just showed you, about 200 billion kilowatt hours a year saved. All the hydro in the United States is a little less than 300 billion kilowatt hours a year. So our 5-year payback on refrigerators contributes almost as much to energy services in the United States as all the dams on the Columbia River, the Tennessee River, the Snake River, the blah, 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 blah. 5-year payback here, you don't get your money back on a dam in 5 years. This is nuclear energy, the total nuclear fleet in the United States. Now, it looks like we have a little bit to do to catch up with them, but I want to replot this not in billions of dollars a year, but in dollars. Not in billions of kilowatt hours per year, but in dollars. This stuff is saved at your meter, and it's worth US-wide, about 9 cents a kilowatt hour. This nuclear energy is, of course, generated, much of it at night, at a bus bar, wholesale, and is worth about 3 cents a kilowatt hour. The difference between this and this is that there's been a transmission system, a distribution system, an energy management system, a little bit of profit, and so on, and it all adds up to a factor of 3. So if I replot this in dollars, then I find that last year, at your meter, refrigerators alone have saved about $17 billion a year. All the hydro in the country at wholesale is only worth about 8, and nuclear power is worth about 22. So if you add improvements in air conditioners to the refrigerators, you easily exceed in contribution to the economy the value of all nuclear power. The problem is nuclear power is big, expensive. Congressmen can get their names on sites and so on. It has lots of lobbyists. And nuclear power is in our future, I'm sure, but I think less of it than the average person thinks. But in fact, I think I'm going to make this point a little bit stronger. This is an issue which comes up in California all the time now. There are 2 ways that you can save a kilowatt of peak power on your new home in, say, Sacramento on a hot afternoon. One is now required by California standards. If it's a flat roof, so there are no architectural issues, the roof must be white. That saves about 20% of the air conditioning load, 20 to 25%, because the roof stays cool and doesn't radiate down on your house. And the new cost to the house is in fact not 0, it's about 25 bucks on a $400,000 house, because the manufacturer puts a little bit of extra fungicide in so that mold doesn't tend to make it look moldy. Or you can put on a solar collector, and that will cost you $10,000. Well, after rebate, it'll cost the state $10,000. After rebate, it'll only cost the state actually $7,000. After rebate, it'll cost you about $5,000, and that will have exactly the same effect. It'll save a kilowatt of peak power. On the other hand, solar is very flashy. It's renewable. It's profitable. There are lots of organizations which are promoting solar. It's a good idea if you've already got your roof white. And there are lobbyists. The white roof went through smoothly with no opposition, thanks to great work by Hashim Akbari over in Building 90, who did all the calculations. But there are no lobbyists for white roofs because there's no profit in white roofs. It just happens. And now, in fact, there's some high-tech work going on in which it turns out that the heat from the sun is 50% visible and 50% near infrared. So if you want a cool roof, but you want it to be brown, you can find a pigment, or green or red. You can find a pigment which is whatever color it is in the visible, and it will absorb up to 50% of the sunlight in the visible, but you can find pigments which are very white or reflective in the near infrared. So there are now cool colored paints. They're half as good as white paints. They cost nothing extra, and they are going to be required starting in 2008 on all new buildings in California, including your residences. They will save half a kilowatt at no cost. At the same time, we're promoting, and I think it's a good idea, solar collectors, but half a kilowatt is about $4,000. We just forget that it's very easy to look around and find efficient things to do. This one sold well in China. It's the same idea as the refrigerator plot, except in this case I'm comparing to something quite different. This purple plot here is the total amount of electricity which will be generated by the world's largest construction project, which is the Three Gorges Dam, in another 10 years when they get all the generators installed, 18 gigawatts. 18 gigawatts, incidentally, is about a third of a California, so it's a significant construction project. The Chinese in the year 2000 introduced refrigerator standards. They had been really terrible before then. This is partly the work of Mark Levine and his China group over in Building 90. And they introduced air conditioning standards. And then they tightened the standards in 2005, and if they went all the way to American Energy Star standards, they would be up here, but the red is actual savings. And I'm going to take 10 years of sales of these equipment. Now, China's a big country. Refrigerators sell about 15 million a year in China now, about 8 million a year in the US. And air conditioners about the same ratio. The savings after 10 years of installing 3 gorges or after 10 years of appliance standards will be comparable in billions of kilowatt hours a year. But remember, of course, this is wholesale power worth, again, probably 2.5 cents, they claim. And this is retail power. The Chinese somehow or other claim that they can get it from 3 gorges on the Yangtze River to Beijing for only a factor 2 instead of a factor 3, the way it costs us. So I put in a factor 2, and this is the economic value of 3 Gorges Dam, and this is the economic value of air conditioner and refrigerator standards. The moral is you need both. But they probably don't need as many 3 Gorges as they think if they tighten up their standards a little bit more and enforce their building standards. This is only appliance standards. Where does this come from in California? This is the California US difference. This savings here amounts to about 1% per year. So let me make a disclaimer now. I showed you that wedge with California flat in electricity use and the United States going up 2% a year. Half of that is probably structural in the weather. I mean, it really, you do really have to air condition less even in Sacramento than you do in Miami. And so we only claim that half of that wedge is energy efficiency. Of that wedge, about a quarter seems to come from appliance standards, about a quarter seems to come from building standards, and about a quarter seems to comes after careful auditing from programs which the utilities offer you to do anything they can to beat the standards. They give you rebates on refrigerators to buy Energy Star refrigerators. They pay $2 cash to any manufacturer anywhere in the world who will sell a compact fluorescent lamp in California. Upstream rebates are a very effective way of doing things. They will give you audits on your house, on your business. They will do anything they can to meet the standards. You pay an extra 2% on your electricity bill, but you actually today you pay about 1.5% extra on your electricity bill, but we knock off demand by 1% every year. So it's a wonderful investment. And that seems to be the way it's going out, working out. This is a picture of Los Angeles from Mount Wilson. If you're energy obsessed, as I am, when you land in Los Angeles, you're always uncomfortable because in the daytime, what you see is hundreds of square miles, thousands of square miles of roofs which are not white. They don't get it yet. They will starting January 1st, but there's still a lot of dark roofs. If it's at night, what you see is these lights. And I point out this is from a mountain, and the same thing is from a plane. This is not light which went onto the ground and is reflected from the streets doing its job. This is wasted light because on the average, street lights and parking lot lights allow light to spill upwards to the tune of 15%. So you see the direct light. We talked with the lighting industry, we passed new standards. The new agreement is no more than 2% of the light will spill upwards. The extra cost is 0. The savings in California Power is about 1% from that single trick. One of the things, one of the measures I want, reality checks I want, this is the famous NASA photograph of civilization as we know it. And over the next 10 or 20 years, as all those damned stupid lights get replaced, California should disappear. Now, this is a plot of the amount of money which California has spent through its utilities on energy efficiency programs. That was the largest single wedge I showed you over the period from 1976 to 2012. And there are a couple of interesting policies here. As soon as the embargo started, the utilities quickly realized that they could save a lot of money in buying new power plants if they went in for energy efficiency. But the problem was the problem was at the time, profits and sales were coupled. That is, every 3 years, these are regulated utilities, every 3 years there was what was called a general rate case. The utility would show what its revenues had to be, what its projected sales would be. The Public Utilities Commission would divide one by the other and say that's going to be the average cost of a kilowatt hour. The trouble with that is then for 3 years, the more kilowatt hours the utility sold, the more profit it made, because there was profit embedded in that calculation. About here, at the beginning of this ramp up, we realized that that was stupid, and that what you want to do is to decouple profits from sales. So you want to say to the utility, here's the rate for the next 6 months, but if you have a vigorous conservation program and you sell less kilowatt hours, we will true up your rates at the end of 6 months so you come out whole. So we completely decoupled profits from sales. This allowed Kafkaesque things to go on. Before the embargo, PG&E was selling both gas and electricity, but electricity was more profitable, and they were selling all-electric kitchens and badly insulated houses. Then we decoupled profits from sales, and the very same salesmen who had been getting bonuses in 1975 for selling all-electric kitchens were getting huge, bigger bonuses in 1976 for selling gas-fired kitchens. It was just quite remarkable, and spending went up this much. Then OPEC collapsed, interest collapsed for a while. Then we decided to jack it up, and we decided to make conservation actually profitable to the utilities, so that for several years, if the utilities had a program which saved Dan Kratz's family $1, the rates were raised after audit the next year so that PG&E got 15 cents back on that $1. So you only got to keep 85%, but it was 85% of a cutthroat, vigorous program instead of 100% of a sort of ho-hum program. And that was this wave of spending. This was crisis spending. Spending went down during restructuring, but now the most interesting thing that's happened is the following. This light green, which you may not be able to see from the back row, but underneath this line is what's called public goods charges. The Public Utilities Commission decided that these programs were so successful that utilities, instead of competing, should just all have to put up 2% of their money for energy efficiency. However, after the crisis, it became clear that the obligation to serve customers was back on the backs of the utilities, that relying on merchant power plants didn't work. And the utilities had to figure out how to meet forthcoming load. Well, the utilities now are realizing that profits and sales are decoupled, said, you know, $250 million or 1.5% isn't enough. We can save a lot more money on energy efficiency than we can on building new power plants. So we are going to voluntarily take a lot of money we devoted for power plants and add it to the public goods charge. And this year, we are now spending $660 million, which is 2 full % of your electricity bill, on energy efficiency programs. We hope to knock this down now 1% a year to energy efficiency for the foreseeable future per person. Population growth will still be about 1% a year, so we'll stay flat, but that's where you can intend to go. So that's my single-purpose, obsessive message, and we want to take some questions? Sure.
I think 20 years or so ago, you mentioned if we all pitted in our Cadillacs for Toyotas, we could join OPEC. If we still have that chance with Priuses in the United States join OPEC, we still have a chance.
What you mean is we wouldn't have to export oil, we wouldn't have to import oil, we could export. Oh, that sounds plausible, but I can't quite do it that fast. What I will do, I can make this point though. There was one slide I skipped over. I'm going the wrong way. This is one which I borrowed from Mark Levine, and it does tell a sort of sad story. This is miles per gallon from 2000 to 2015. Today is right around here. This is the U.S., which, along with its SUVs, is stuck at 24 miles per gallon. Even China, which is not supposed to be that much advanced ahead of us, at 30 now and headed for 38. Europe headed for 55 or something. So we're really doing a shameful job of fuel economy, but I can't answer your question. I can tell you one other number that comes to mind, though. And I think this is so shocking I should train myself to remember it. If we go back to this, and we ask, how many cars off the road does this virtual reg correspond to, the $75, 75 quads? The answer is 1 billion cars. Now, the world's supply of cars is only 600 million. So pollution-wise, just the United States getting its act together is equivalent to not having 1.5 times as many cars as there are crowding up the atmosphere as there really are today. So, Carl, I thank you for your comment. I didn't answer your question.
Answer anyway.
Yes.
Okay, so as Carl pointed out, when we think of energy conservation we can do by just acting differently, we think of buying a Prius. Maybe we think of getting solar power panels and solar heating. But your analysis of red state versus blue state and California versus U.S. was only electricity.
Right.
You're telling me so you're telling Californians and New Yorkers buy more efficient refrigerators and air conditioners, and that's the only difference between, that's the principal difference between the California, New York, and the...
No. It's not just appliance standards. It's that whole wedge which I showed you of about 1/4 of the effect is appliance standards. 1/4 of the effect is building standards. And half the effect is very vigorous programs by the public utilities programs to induce you, to seduce you to whatever you want, to incent you to buy Energy Star equipment and so forth and so on. And in fact, appliances is a mixed bag, because remember, the major appliances are in fact national and updated by DOE. It's only the loopholes. Basically, what we do in California is we take anything that's Energy Star, voluntary in the rest of the country, and we make it mandatory in California. But it has 5-year payback, so it goes pretty well. But no, building standards are very important.
So answer, it's the failure of national standards.
It's a failure of national standards, right. Or partial failure of national standards. They're not as tight as, right there.
In Illinois, up to at least 10 years ago, the amount you paid for electricity went down as you used more, whereas in California, it goes up as you use more.
Right.
It's power company policies that determine a lot of that. Was that
Chuck Rose says, in some states there are still what are called declining block rates. The argument was it's cheaper to serve you electricity in large spoonfuls than in small quantities. In California, we're just the opposite. There are 5 tiers. Tier 1 and Tier 2 are almost lifeline rates. They're very low. And then it gets very expensive as you go up. Chuck, I really don't know what to say, except I think that illustrates a big difference in attitude. And
red versus blue?
Louder.
Red versus blue.
Red versus blue, perhaps. I will tell you, Illinois is going to go in for a very aggressive energy efficiency program now under Exelon. They've decided, they've got the word too, and they've decided it's cheaper to do energy efficiency than more power. Again, I don't have a very good answer for you.
So if you put in a nice efficient, 92% efficient gas furnace, there's still a fan on the darn thing, which I calculate is one of the biggest energy eaters in our house. Isn't this accurate?
Yes, and that's one of the reasons we're suing DOE, because they haven't updated. We agree completely. The fan energy was not part of the early test procedures. It absolutely should be, and we want it changed.
I think of the Netherlands as a progressive bicycle riding country. Why are they so high up in your chart in having an accident?
You know, that's a good question. They're also a highly industrialized country, and to be perfectly honest, I just don't know. I wondered about that too. So all I can say is I'm glad you're alert.
You've alluded throughout your talk in nice and indirect terms sometimes about the politics of energy efficiency, and you've had a long history in that area. I'd like to hear just some of your insights of the past and perhaps present and future in that, how that affects the actual energy efficiency applications that you actually see coming down the pipe.
Well, if you just want two personal comments, one which did surprise me quite a lot is how California was already pretty convinced that global warming was a problem and they should pass the Pavley bill and so on. But Governor Davis, a Democrat, isn't nearly as aggressive on energy efficiency as Governor Schwarzenegger, which surprised me quite a lot. I didn't take all that very seriously before he came into office. But he's convinced that global warming is a serious threat. He has toyed with the idea of even a cap-and-trade program, although that's being held. But he signed an executive order requiring a 20% increase in the efficiency of government buildings, and has appointed a very high-level task force to do that. He's all behind the California Solar Initiative, which is to put 1 million solar roofs in place. So it's been gratifying to see that energy efficiency can be a bipartisan issue, at least in some states. The only other thing I can say is very vague. I think that the global warming issue is what's going to continue to trigger more energy efficiency. My impression is that Americans really are beginning to say, boy, sea level rise is a problem. Katrina was probably worse because of, Katrina was not entirely the incompetence of the engineers. It may have been also something to do with the water temperature. And I think we're going to see more and more states paying attention. But I read the same newspapers you do. I'm not sure that I'm that well equipped.
So if we had 1% of the planet painted white, would that help?
Oh, yes. Let me, thank you. I'm getting out of this I'm getting over here, I guess. That's where I'm supposed to be because it's being taped. I forgot. That's a nice note on which to end. Urban heat islands have been studied for a long time, mainly by the Heat Island Project here under Hashim Akbari. And the idea is that you can not only save air conditioning under a house by putting a roof white, a white roof, or cool colored roof, but if you also go for cooler colored pavements, which means white aggregate in the asphalt instead of dark colored rocks, again, usually it costs nothing, and you plant some more trees to get a more evapotranspiration, you can lower the temperature of cities by typically 10 degrees Fahrenheit. Fahrenheit. Which would in fact offset the heat island, which is Los Angeles right now. Carl knows that. Now, that's a good idea per se, but then Hashim Akbari and I and Dr. Menon over in Building 90 got to thinking, if we had a serious white roof program and we could sell cities all over the world the idea of going in for white roofs to save smog, to save temperature, to be more comfortable. But what would it do to the world's temperature? Well, this involves what is known as the albedo effect. Most famous example is Alaska. The world temperature today is only up 0.8 of a degree on the average, but Alaska is up centigrade. I'm switching to science now. The world is up 0.8 of a degree centigrade, but Alaska is up 3 degrees centigrade. Why is that? Well, it's the albedo effect. It's the fact that the ground used to be thawed and dark as opposed to snow-covered like 8 weeks out of the year, but now it's 15 weeks out of the year, and the albedo difference between snow and ground is really a lot, and so Alaska and the poles heat up very sensitively. So there's nothing to do with CO2. To offset it, you might need tons of CO2, but it's nothing to do with CO2. The world is now about half populated, about half the population of the world lives in urban environments, and that's about 1% of the world's land mass, or about 1/3% of the total world's volume. If you calculate how much that would cool the world, and we did this years ago, and it didn't seem very interesting. It was let's see, the way I remember it, I wasn't prepared to say this, I have to think out loud. We are now heating up about 3 degrees in the next, let's say, 60 years, so that's like 0.05 degrees per year. This effect would be like 0.02 degrees per year, like 4 or 5 months. Well, at first, we never said anything about that because 4 months delay in global warming seems sort of ha-ha. On the other hand, if you convert it to the amount of CO2 which you have to remove to get that effect, then it turns out that that's equivalent to not burning any carbon dioxide in the world, not burning, no flames for 6 months or 4 months, which is equivalent to 1/3 of a year at 6 billion tons of carbon per year. So it's like 2 billion tons of carbon, and they're trading in Western Europe now at $100 a ton. So it's a huge effect. We've never gone public with this because we're trying to get the numbers straighter, but it is an interesting effect, and it would delay global warming by a few months. And if we could get some sort of UN program which said to, say, the city fathers of Shanghai or Beijing or New Delhi or whatever, if you start a white roof program, we'll give you $20 million to get started. That turns out to be equivalent to saving carbon. It's not at $25 or $50 a ton, but more like 5 cents a ton. So it's an interesting idea. That's another conservation idea which you reminded me of, so thank you, Carl. Okay, we should quit.
Thanks again.